This video is going to be about everything Surds. So whether you are a beginner or you're partway through your journey with Surds, this is going to be a whistle-stop tour of everything you need to know. It's going to be a long one, there's a lot in here, so bear with and do your best. Remember, you can always do a part of the video and then come back a bit later on. Just a reminder that Surds is only on the higher tier GCSE, and so if you will be sitting foundation, you do not need to do this lesson unless you're looking for a bit of independent study for yourself to take yourself beyond, maybe if you're thinking about the future. You will need something to write with and on, and whilst everything I'm going to show you today is designed to be non-calculator, it's all to do with manipulation. If you want a calculator to hand to help you out or to check answers, you're more than welcome to. I'm going to jump right in, so if you need a bit longer to read the task board, please pause the video so you can do that and hit play when you're ready. A surd is an irrational number found by taking the square root of a non-square number. It cannot be simplified into a rational number. There's a lot to unpick there, so let's have a look. So rational numbers can be simplified into an integer, fraction, or terminating decimal. That's a decimal that eventually does end. Examples, the integer or whole number 5, and remember integers can be positive or negative, like negative 12. We can have a fraction in its simplest form, so 2/3, or a terminating decimal, so that is just a decimal where the decimal digits do eventually end. For example, 6.125. So they are all rational numbers. Irrational numbers cannot be simplified. Even when expressed as a decimal, the digits would just go on forever. If you've come across pi before, you will recognise that. That is a decimal where the digits have no end. They just go on forever. Pi is an irrational number. And one type of these numbers are surds, and as per the definition, it's found when we're trying to take the square root of a non-square number. For example, the square root of 2. If we try to take the square root of 2, it's just not going to simplify to an integer, like for example, if we did the square root of 25, we would get 5. Which is a whole number, or the square root of 4 is 2. The square root of 2 we can't simplify, and if we type it into a calculator, it will get this decimal down at the bottom, but these digits will just keep going forever. One of the things we can do, however, is to simplify surds. Notice the command word here, simplify, and that means we can reduce the value that is contained within the square root sign. Almost think of it like writing fractions in their simplest form. So what we're going to do is, underneath, we're going to give ourselves 2 square roots being multiplied together. And the 2 numbers we're going to put in these square roots need to multiply to get our 24. But there's one key rule we have to follow, and that is in the first one, we have to put a square number. Now just a reminder of square numbers, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so on. And the square number we choose needs to be the largest one that will be a factor of 24. So looking at that list, the biggest square number that goes into 24 is 4, and we make 24 by doing 4 times 6. So these two things are equivalent. Root 4 times root 6 is root 24, that's the same thing. But what we know is we can simplify a square root of a square number. The square root of 4 is just 2, but we cannot simplify root 6. That's another example of an irrational number. We can't do anything with it, and so we're going to keep it the same. And much like with algebra, we can just write these side by side. We don't have to put the multiplication symbol in between. So when we tidy all this up, the simplified form is 2 root 6. There are 3 questions for you to have a go at. Pause the video and hit play when you're ready to see the answers. For the square root of 20, I'm once again going in with the square root of 4 being the biggest square number, and 4 times 5 makes 20. The square root of 4 simplifies to 2, so my final answer is 2 root 5. With the square root of 45, I know that root 9 goes into root 45, and 9's the biggest square number. The square root of 9 is 3, so our answer is 3 root 5. And for our last one, I know that 100 is a square number that goes into 300, and so our final answer will be 10 root 3, because the square root of 100 is 10, the root 3 stays the same. We've then got multiplying and, in turn, simplifying surds. As we've just seen from the previous example, the multiplication of 2 surds is as straightforward as it gives you that surd in one singular square root. So root 6 times root 8 is root 48 because 6 times 8 is 48. However, we can then simplify this just like we've been doing before. So I know that the largest square number that goes into 48 is 16, and it will go in 3 times. The square root of 16 is 4, so the answer is 4 root 3. Here are 3 questions for you to have a go at. Pause the video and hit play when you're ready to see the solutions. So I know that root 10 times root 6 is root 60. The largest square number that goes into 60 is 4. So that will be 4 root 15 because 4 times 15 is 60. And the square root of 4 is 2. So 2 root 15. For this second question, we've got root 12 times root 2, which I know to be root 24. That simplifies to root 4 root 6, which simplifies to 2 root 6. So this one was 2 root 6. And our last one, root 60 times by root 8 is root 480. I know that 16 goes into 480 multiplied by root 30 based on the example I gave on the left, which simplifies to 4 root 30. And as you can probably imagine, division works in much the same way. Root 30 divided by root 6 is simply root 5 because 30 divided by 6 is 5. If you have an answer that simplifies, then make sure you do that as well, but for me root 5 is as simple as we can go. Here are 3 questions for you to have a go at. Pause the video and hit play when you're ready to see the answers. Root 12 divided by root 2 is root 6. Root 35 divided by root 5 is root 7. Neither of those can be simplified. Root 45 divided by root 5 is root 9. And you may have left that like that, but well done if you spotted that that is in fact a square number, so it's not a surd. The square root of 9 is just 3, the integer 3. And so if you simplified to 3 and spotted that, well done. With these next set of examples, you can almost think of these like algebra. What is in the square root needs to be alike in any terms that we add or subtract. Imagine you have 2x plus 5x. Very similar to this question. We've got 2 root 3 plus 5 root 3. Well, 2x plus 5x would be 7x. That x has remained the same throughout the calculation. That's also true of this. If we've got 2 lots of root 3 and 5 lots of root 3, altogether we have got 7 lots of root 3. So that's how we'd answer that first one. We've got to make sure that the surd part is common to both terms. When you've got a question like the second one, we've clearly not got anything in common. So we need to make something in common by simplifying these 2 surds. We can simplify root 125 into root 25 times root 5, which simplifies to 5 root 5. And we can simplify root 80 into root 16 times root 5. And it's always a bit of a clue when you've done the first one. You know what root you're going to be looking for in the second one because it has to be the same, which simplifies to 4 root 5. Therefore, our answer, 5 lots of root 5 and 4 lots of root 5 would be 9 root 5. Here are 3 questions for you to have a go at. Pause the video and hit play when you're ready to see the answers. Okay, nice and straightforward on the first one. If we've got 3 lots of root 7 and we add to that 6 lots of root 7, we have got 9 lots of root 7. This second one, we have nothing in common, so we're going to have to make something in common. Root 24 is the same as root 4 root 6, which is 2 root 6. And root 54 is going to be the square root of 9 times the square root of 6, which is 3 root 6. And so if we add those together, 2 lots of root 6 plus 3 lots of root 6 will be 5 lots of root 6. And then once again, nothing in common. Root 90 can be made by doing root 9 by root 10, which is 3 root 10. And root 40 is root 4 root 10. Square root of 4 is 2, so 2 root 10. And 3 lots of root 10 take away 2 lots of root 10 is 1 lot of root 10. But whilst I'm here, let me just point out that 1 lot of root 10 can just be written as root 10, just like we do with algebra. So I would say actually this one just equals root 10. Well done if you're sticking with it. We're moving into another section now, which is expanding brackets. I'm going to assume that you'll have seen expanding brackets with algebra before, but if you haven't, don't worry, you should be able to pick it up as we go along. When we've got a number on the outside of a single bracket, we are going to multiply that number by all of the terms inside the bracket. So here we've got 2 terms. We've got root 3 and we've got 4 root 5. So we're going to do 2 times root 3, which is simply 2 root 3. And we're going to do 2 times 4 root 5. Remember, that's already 4 lots of root 5. So if we times that by 2, that will become 8 lots of root 5. In this second question, we've got 3 root 2 times root 3. And because we've got 2 roots, it's the parts in the roots that we multiply together. So that will be 3 root 6, because root 2 times root 3 is root 6. Pop the minus in. And 3 root 2 times 5 root 5. We multiply the integers and then we multiply the roots. So 3 times 5 is 15, root 2 times root 5 is root 10, and there's nothing here that can be simplified. So we just leave our answer like that. If there's no like terms to group together and we can't simplify them to make any like terms, we're done. Here are 2 questions for you to have a go at. Pause the video, hit play when you're ready to see the answers. So we've got 4 times root 6, which is 4 root 6. And we've got 4 times 3 root 2, which is 12 root 2, and nothing can be simplified here. In your second question, we've got 2 root 10 times root 7, which is 2 root 70. 2 root 10 times 9 root 3 is 18 root 30. And once again, we've got nothing that can be simplified there, so we're going to leave our answer like that. When we multiply double brackets, so as you can see, we've got one bracket here next to another bracket, we have to multiply everything in the first bracket by everything in the second bracket. So I'm going to do this one at a time. So I'm going to start with the 2, and I'm going to multiply it by 4 root 3. That will be 8 root 3. Back to the 2, and we're going to multiply it by root 12. So that would be 2 root 12. So that's the 2 has been multiplied by both terms in the second bracket. Then we move on to the root 3 and multiply it by 4 root 3, which would be 4 root 9. And then root 3 times root 12 would be root 36. Those are our 4 terms we get from expanding 2 things by 2 things. Now you may have noticed as we went along, some of these things can be simplified. 8 root 3 can't, that's going to stay the same. However, root 12 is the same as root 4 root 3, which is 2 root 3. And so when we multiply that by the 2 in front of the root 12, because remember it's 2 lots of root 12, so we need 2 lots of 2 root 3, that will be 4 root 3. We've got 4 lots of root 9, but we know root 9 is just 3, so 4 times 3 is 12. And the square root of 36 is 6. And then we can simplify. If we've got 8 lots of root 3 plus 4 lots of root 3, that's 12 lots of root 3. And 12 plus 6 is 18. Not all answers will simplify to something like this. Some of them you might be able to simplify into 3 terms. Some of them you might have to leave as 4 terms. It really depends on the question in front of you. Here's one for you to have a go at. Pause the video, hit play when you're ready. So we've got 5 times 7 root 2 is 35 root 2. We've got 5 times root 8, which is 5 root 8. We've got root 2 times 7 root 2, which is 7 root 4. And we've got root 2 times root 8, which is root 16. If we do a bit of simplifying here, that first term is going to stay as it is. Root 8 is the same as root 4 root 2, which is 2 root 2. Don't forget that needs to be multiplied by this big 5, so we've got 10 root 2. 7 root 4, well the square root of 4 is just 2, times by 7 is 14, and the square root of 16 is 4. which means we've got 45 root 2 plus 18. You're doing really well. I've got 2 more slides of examples to show you. And now we're moving on to rationalising the denominator. All that means is we cannot have an irrational number in the denominator, which is the bottom of the fraction. So we've got to get rid of that surd on the bottom of the fraction. Doesn't matter though if we've got one in the top. To do that, we are always going to multiply by the surd over itself. Because we know anything divided by itself is equal to 1. So that means I'm only multiplying by 1, which will just get me the same answer. So I'm not changing the value of the surd, I'm just manipulating it and changing the way it looks. 2 times root 3 is 2 root 3. And root 3 times root 3 would be root 9. Let me just do a little side note here. Though on the bottom, root 3 times root 3 is root 9, but that just simplifies back to 3. And the reason for that is because essentially you're doing root 3 squared, because you're timesing it by itself, and squared and square root are inverse operations and they just cancel each other out. So you're just left with the number in the surd. So that's the final answer for that one. With this one, same process. You don't have to times by the whole denominator. You can, it will just mean you've got to simplify your answer, but you can just multiply by the surd part. So 5 times root 7 is 5 root 7. 2 root 7 times root 7 is 2 root 49, but we know root 49 is just 7, so it's essentially just the same as doing 2 times 7, which is 14. Let me just do that to the side. So we've got 2 root 7 times root 7, which is the same as 2 root 49. The square root of 49 is 7, so it's the same as doing 2 times 7. Here's 2 for you to have a go at. You know the drill. Pause the video, hit play when you're ready. We're going to multiply this by root 2 over root 2, which is 12 root 2. And root 2 times root 2 is just 2. Now, in my examples, we didn't get any that simplified. Yours actually can, because you can divide 12 by 2 and get 6 and 1. And when we've got 1 on the bottom of a fraction, we don't have to bother writing it. So the answer to this one was just 6 root 2. Don't worry if you didn't spot that last step, as that wasn't in my example, but now you've seen it and now you'll know. And for this one, we will be multiplying by root 5 over root 5. I'm going to do my answer over here just because I've not got much room. 10 root 5 on the top. And root 5 times root 5 will just be 5, times by 3 is 15. And once again, we can divide both of these by 5, which gives us a final answer of 2 root 5 over 3. Squeeze that in there. Last example. Slightly more complicated, the most challenging sort of surds question you're going to get, so well done if you're still sticking with it. For this one, it's a little bit trickier to get rid of the surd on the bottom. So what we're going to do is we're going to multiply by the denominator, but as you can see, it's now got 2 terms on the bottom separated by a minus. Whatever that symbol is, we need to do the inverse, and I'll explain why as we go. It will make sense when we get there. So I'm going to multiply it by 5 plus root 3 over itself. So when we come to expand this, we've got, you can almost think of this as being in brackets, this being in brackets, this being in brackets. So on the top, you've got 2 times 5, which is 10, and 2 times root 3, which is 2 root 3. Then you've got 5 times 5, which is 25, plus 5 times root 3. Then you've got minus root 3 times 5, which is minus 5 root 3. And minus root 3 times root 3 would be minus root 9, which is just 3. Now hopefully what you can see here in the middle is we've got a positive 5 root 3 and a negative 5 root 3, which are going to cancel out with each other to get 0. That was why we swapped the sign in that first step. We needed one positive and one negative so that when we expanded it, they'd cancel each other out and we'd have no surds left on the bottom. So that and that will cancel and we're just left with 25 take away 3, which is 22. And on the top, we've got that 10 plus 2 root 3. And this one can actually be simplified. It's a bit of a weird simplification, but when you've got more than one term on either the top or the bottom, if you want to simplify, you've got to be able to divide every single term by the same thing. Luckily, we can divide everything by 2. That would give me 5, 1, and 11 if I divided everything by 2. If you could only divide one of these by 2 and not both of these terms on the top, you couldn't do it. You can't simplify it. It has to be everything. So we're left with 5 plus 1 root 3. Remember, I don't have to write the 1 over 11. I told you they get a bit tricky, but that is as bad as they get. 2 for you to have a go at. Pause the video, hit play when you're ready for those final answers. So we're going to be multiplying by 2 plus root 2 over 2 plus root 2. I'm going to do my working out at the top. So this will get me 6 plus 3 root 2 over 4. Now I know already that those middle terms are going to cancel out. So that just means I've got minus root 4, which would be minus 2. So that's going to get me 6 plus 3 root 2 over 2. And that is my final answer. And this is an example where it won't simplify, because I could do the 6 divided by 2, but because I can't do 3 root 2 divided by 2, I can't simplify it at all. So it has to stay as that as my final answer. And now for this last one, I've put my face in the way. So I'm going to do my little bit of working out up here. I will squeeze it in one way or another. So we're going to be multiplying by 7 minus 3 root 5 over 7 minus 3 root 5. You're going to have to trust me that that's there. Working out. 4 times 7 is 28. 4 times negative 3 root 5 is negative 12 root 5 over 7 times 7 is 49. I know the middle terms are going to cancel out, so that just leaves me with 3 root 5 times negative 3 root 5, which will be negative 9 root 25. Now, 9 root 25 is the same as 9 times 5, which is 45. So 49 take 45 is going to put me 4 on the bottom. So we're going to end up with 28 minus 12 root 5 over 4. All of these terms can be divided by 4, so this one can be simplified. 28 divided by 4 is 7. 12 divided by 4 is 3, so 3 root 5. And 4 divided by 4 is 1, so I don't have to put the 1 on the bottom. So that there, 7 minus 3 root 5 is your final answer. Well done if you got through that, and I do apologise. It's really bad practice of me to do my working out like this all around the edges of the page. Hopefully you did yours a lot more neatly and concise. Okay, let's go through some quick multiple choice questions now. Based on the question, I will put an appropriate timer on the screen, but if the timer doesn't work for you, feel free to pause the video and use as much time as you need. First questions, which one of these is a surd? If you said B, you would be correct. Simplify root 80. That one was C. Simplify root 50 times root 5. That one was D. Simplify root 48 divided by root 6. That one was B. Simplify 2 root 3 plus 5 root 3 minus root 48. If you said C, that's correct. On to some expands. So we've got 5 multiplied by 2 root 3 plus 4 root 6. That one was B. Double brackets this time. That one was B. And lastly, and that one was C. Just a little note on that one as well, in that how the answer is structured. I left this one structured as you would probably have naturally got to it through your working out. However, some mathematicians may find having this negative on the bottom of their fraction untidy. And so they would make that a positive on the bottom by making everything on the top negative, which would look something like this. So we've made the 6 negative. Because the 12 root 2 was already negative, that's become positive. But even still, they might find that a bit too untidy with the negative being at the start. So then they'd swap around the terms in the numerator to read this. They all mean the exact same thing, and in an exam you're going to get the marks no matter how you write it. But if you did express it in a slightly different form because you tidied it up at the end, any of these answers would be correct. And just because this video wasn't already long enough, here is some independent practice if you want to have a go. Well done if you really are committing to this amount of work. This really has been a whistle-stop tour of all things Surds, and usually on these end screens I put about 6 to 10 questions on. You've got quite a few, but if you really do want to be confident with this, it is important that you do get some practice in. So pause the video one last time, and when you hit play, I'll be popping the answers on the screen. And here are your answers. Go through and check those. If there's anything you didn't understand, feel free to watch the examples again if you fancy spending a little bit longer on Surds. Or if you want a direct explanation, then feel free to put anything you're unsure about down in the comments and I will reply to you. We do try to reply to every comment we get related to the subject content in the videos. And with all that said, the biggest well done for surviving such a long video lesson and engaging, especially if you've gone all the way and made it to the end. This will greatly help you when it comes to sitting your exams. Make sure you like the video and subscribe if you're not already. I'm always here, I'm always on hand to help you with your revision to get ready for your GCSEs so that you are giving yourself the best opportunity to smash those. If you also like short form content, we are also on Instagram and TikTok where we post short revision quizzes and some tips, so be sure to follow us over there as well. I'm Charlotte, well done for today and thank you for watching this video.